I'm going to be discussing and demonstrating some cleaning and maintenance of our urine SediVue analyzer. The urine sample is pipetted in through this little window onto a specially designed slide, which is then drawn into the machine and read with a little camera. So it's important that this area be cleaned frequently. There are weekly cleanings and monthly cleanings in order to keep this area free from any urine backsplash. The first thing to do is remove the backsplash, remove the tray, and remove the filter in the back. These can be cleaned by running them under tap water. And drying with a paper towel. Go ahead and replace the backsplash, the filter, and the tray. Next, I'm going to remove the magnetic slide holder. This device actually holds the slide which contains the urine sample, so it's important to make sure that this is in clean working order. I'm using an alcohol prep pad to clean everything, and then using a new prep pad, I'm going to clean the actual camera in a circular motion and then wipe towards me, and then with a dry corner, drying it off in a circular motion, wiping towards me. There's a little lever here that is used to hold the slide in place and then to discard it into the waste container. So it's important to move the lever while cleaning this device because urine can get caught in several places. And then just cleaning off the other surfaces. This is the cartridge that holds the slides, so making sure there are cartridges in there, which there are. Replacing my magnetic slide holder, and then closing my machine. The last step is to empty the waste container. This can be emptied into the garbage and just holds the discarded slides. And now that our machine has been thoroughly cleaned, it is waiting to give us the okay to use it. And once that turns green, that is now green. That means that we can use the machine, and the machine is in good working order. Now, quality control on this machine is done by the company that issued it, IDEX, but it is important to make sure that the weekly and monthly maintenance and cleaning is done on it to ensure good working order. Alright, I'm going to be demonstrating an enzyme-linked immunosorbent assay test. I've got my blood that was drawn up in a heparinized syringe so that it does not clot. I'm going to put 4 drops of my conjugate into a plastic container. And the actual test I'm going to be doing is the canine heartworm 4DX test, which is the most common ELISA test we do in our clinic. So 4 drops of conjugate, 1, 2, 3, 4. Then I'm going to do 3 drops of blood.
One thing we can't do is have
Put the needle off.
Or somebody we've lapsed in seeing they're not current. We test them,
so
we
3,
give them their prevention, we give them their
1,
vaccine,
2,
and then their test
3.
comes up positive for something. They then now need treatment.
That mixture is then going to be placed into this snap device. It will be placed into the well. The mixture will then travel up to this little window where I will then snap the device. The whole system will flush, and then we'll time it for 8 minutes once it has been snapped, and then interpret results. So I'll go ahead, drop the whole mixture,
If it's not, then we do have to have it documented.
place it into the well,
And there's different ways to do all that kind of stuff. I do understand,
and then just going to wait while the whole mixture travels up to the window. Nearly there.
Right. That is a more common thing. It's becoming a lot more prevalent that people are getting those policies. I certainly don't have those policies on
And
my
I am
own as
starting
well,
to
but
see
I've
some red in the little window. So then we're going to snap it.
13-year-old and a 12-year-old. So,
And time for 8 minutes.
Time that I
Alright, we are going to interpret the results of the ELISA 40X test. So here it is. It is all negative, and I can tell that because our control dot, we've got our control dot there. If it was positive for anaplasma, we would have a dot right there. If it was positive for heartworm, we would have a dot right there. If it was positive for Ehrlichia, we would have one right here, and if it was positive for Lyme's disease, we would have one right there, but we just have the control dot, which means that this test is all negative. Demonstrating a simple fecal flotation. So I've got about 2 to 5 grams of feces in my plastic cup here. I'm going to fill about 30 mils of my fecal flotation solution and just mix it up really well. Get a good emulsion. And then I'm going to strain it through some gauze into my tube here. And then I'm going to strain it through the gauze again in order to get a meniscus on the top. Right, we've got that meniscus. I'm going to place a cover slip over the top of the meniscus of the fluid, and we'll wait 10 to 15 minutes. Okay, after 10 to 15 minutes, we'll take the cover slip from our fecal flotation, place it right on a slide, and then this is what we would examine under the microscope for ovaries and parasites, and we do know that this patient sample is all negative. Alright, I'm going to be demonstrating a direct fecal smear. I'm going to get some 0.9% sodium chloride, just a little bit, and I have my slide here. I'm going to place just a few drops of the saline on the slide. And then using a wooden applicator, try and get an equal amount of my fecal sample here onto my slide. And I'm going to mix it around and make an emulsion. And then I'm going to get rid of that excess fecal material. Just got my emulsion here. Get rid of some of those bigger chunks. Alright, and then the film should be clear enough to read through, so I can see through that. I've removed most of the large pieces, so I will then place a cover slip on top. And then this would be viewed under a microscope starting on the lowest power at 10x, and then some direct smears can be read on 40x as well. And after testing the patient with our direct smear, the sample was found to be negative. Performing a fecal centrifugation with flotation, I've got about 2 to 5 grams of my fecal sample here. I'll add about 30 milliliters of flotation solution. Just mix it up really good to get a good emulsion. And then I'm going to strain it through some gauze, some cheesecloth again. Into my centrifuge tube. Alright, and get it close to the top, but not right at the top. And I've got a tube with an equal amount of water, so I'll put this in the centrifuge. Centrifuge the sample for 5 minutes. Alright, our sample is done centrifuging, so I will grab it out. You can see the sediment has formed on the bottom there. So I will fill tube the rest of the way until a meniscus forms. And then place a cover slip over it and let it sit for 10 to 15 minutes. After 10 to 15 minutes, we take our cover slip, place it on a slide, and then this would be read under the microscope for ovarian parasites, and we would find that the sample for this patient is negative. I'm performing a fecal sedimentation, so I've got about 2 to 5 grams of my sample. I'll add some tap water, and then using a tongue depressor, really mix it up and get a good emulsion. A little bit more, which I will then strain through some cheesecloth into a centrifuge tube. And I can stop just short of the top. And I have a tube with an equal amount of water. So I will then centrifuge. I could let it sit for 30 minutes or centrifuge for 5 minutes, and I'm going to opt to centrifuge for 5 minutes. Our fecal sedimentation is done spinning. So we'll get it out of the centrifuge and we can see the sediment. So I'll quickly pipette off the supernatant. I'm going to be really careful to not disturb the top layer of sediment. I have my slide, my microscope slide. I will carefully remove just the top layer of sediment. Place it on the slide with a cover slip, and this would be examined under a microscope for ovarian parasites, and we do know that the sample for this patient is negative. I'm going to be doing an ear swab on a dog. This dog has an ear infection, so I'm going to lift up the pinna of the ear, insert my cotton applicator in the ear canal very gently, and I did get some stuff out, so I'm just going to break the tip to denote that that's the left ear so I don't get my swabs mixed up. I'm going to do the same thing on the right ear. Inserting into the ear canal very gently, just kind of moving my applicator around, drawing out a little bit deeper. Alright. Now I'm going to take a glass slide, and this is the right ear, so I'm going to keep it on the right hand side. Just roll that cotton applicator on the slide. Take my left ear on the left side, roll that around, and then I'm going to use a flame and heat up the cells so that it fixes them onto the slide. I don't want to heat it too much because I don't want to lyse the cells. And then I am going to put it through our dip quick stain. So 10 dips in each stain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Rinse this off under some tap water. And I'm just going to dry off the bottom and make sure that we get all of that extra ash off the bottom there. I'm going to tap it dry, and then I'm going to read it under a microscope. I'm going to start on low power on the left side, kind of briefly scanning, making sure that everything's in focus, moving up to medium power, and then moving up to high power. And my goal is to read it under oil immersion. I've got it on oil immersion, focusing in, seeing a lot of epithelial cells, which is pretty standard of an ear swab. And what I'm looking for is either yeast, which look like dark purple kind of bowling balls, or cocci, which are smaller spherical purple dots, usually paired. Occasionally we do see rods in bad infections, and I'm not seeing any pathology in this ear, just a lot of epithelial cells. So this ear is clear. Just going to look at the other ear, so the right side. And I do see some yeast and some cocci, so a little spherical purple cocci and budding yeast. So this dog does have a moderate yeast infection and moderate cocci infection in the right ear. I'm going to demonstrate a skin scraping on a dog. I've got my slide with some mineral oil on it, and I've got my surgical blade, so I'm just going to dip the surgical blade in the mineral oil, get it nice and moist, and then I'm going to take a fold of skin, and I'm going to scrape my blade up, so my blade is pointing down. I'm going to scrape it up against the skin until I get just a little bit of capillary oozing. So I see it's starting to get a little red and oozy there with the capillaries. And then I'm going to place my sample in the mineral oil here. Isolate another area. And do the same thing. Scraping up until I get just a little bit of capillary bleed. And placing that sample in the mineral oil as well. And that's how to do a skin scraping. I'm going to be examining my skin scraping under the microscope. So I've got my skin scraping slide here. Place it under the microscope and begin scanning on a low power 10x. I'm just focusing in so I can see my sample, kind of get a good visualization of what I'm looking at in general. And what we were looking for on this particular patient were Demodex mites, which is why we did the skin scraping initially. Alright, so on initial examination, seeing a lot of small pieces of hair, lots of keratinized epithelial cells, which I would expect from a skin scraping, not seeing any mites. So we can go on a higher power, focus in, still just seeing epithelial cells and hair. High 40x power. Still no mites visualized at this point. And then under oil immersion, again, I'm just seeing hair and skin cells, epithelial cells. So this dog is negative for the mites we're looking for, which is good news for him. When a suspected rabies patient comes in, then only titered and vaccinated personnel are allowed to handle the patient while it is alive. If the animal is to be euthanized, then eye protection must be worn along with gloves and a gown. After euthanasia, the head must be removed and submitted. The state gives us a special box to put the head in, along with specialized paperwork that is not allowed to be opened up until such time as it is needed. If the head does need to be refrigerated before it is shipped, if it's going to be a while before shipping, and then we just take ours right down to the State Department. The remainder of the body cannot be dispensed back to the clients. It must be disposed of by the veterinary clinic, and it must be cremated. Doing our vaginal cytology, so our doctor is going to scrub the vulva with German chlorhex solution. And then we're taking sterile cotton swabs and wetting it with sterile saline. And then that will be inserted into the vulva. And the doctor's taking the swab, and then that swab will then be gently rolled out onto a slide. Perfect. And if you want to follow me, we're going to go into the lab. This will then be stained in our 3-step diff quick stain. So dunk 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the 4 different stages of estrus are anestrus, proestrus, estrus, and then metaestrus. And with anestrus, we would be expecting a lot of intermediate and parabasal cells with large nuclei, some red blood cells, and some neutrophils are possible. Proestrus is marked by the beginning of cornification of cells, of the intermediate cells, some more of the superficial cells, and then lots of red blood cells, lots of neutrophils. Estrus is marked with almost entirely the superficial cornified cells, and then very little red blood cells, and then metaestrus is marked with more of the intermediate cells and lots of bacteria. So just briefly scanning my microscope under low power. I'm going to my medium power and up to high power. And initially I'm seeing a lot of neutrophils. I'm going up to oil immersion. I'm seeing a lot of neutrophils, a lot of red blood cells, and the epithelial cells that I'm seeing do have nuclei, and the cells are rather large, like I would expect intermediate cells to be, with lots of blood cells surrounding. So I would say this dog is in proestrus. I've got my clotted samples where I'll obtain my serum from my donor and recipient, and my anticoagulated samples from my donor and my recipient, and they're all equal volumes, so I will centrifuge them against each other for 5 minutes to obtain my red blood cells and my serum. Samples are done spinning in the centrifuge, so I'll remove them one at a time. I'll first take my donor serum sample and place it into a plain red top tube labeled donor serum. And just set that aside for later. Take my recipient serum sample, place it in a plain red top tube labeled recipient serum. So we've got some recipient serum, and I can kind of tell that is a little hemolyzed naturally, so I have to keep that in mind. Alright, my donor red blood cells. I'm going to remove the supernatant, which is the plasma layer. It doesn't look like it's very thick. Alright, remove some of that plasma layer. I'm going to take 2 drops of my red blood cells from my donor and put it into a plain tube labeled donor red blood cells. Donor red blood cells. So just 2 drops of red blood cells. 1, 2. Set that aside. And then my final tube for my recipient red blood cells. Remove the plasma layer. Which is hemolyzed. And place 2 drops of red blood cells for my recipient. 1, 2 in a plain tube. And set that aside. And then I will start my red blood cell washes. My red blood cell washes, I've got my donor red blood cells, my recipient red blood cells. I'm going to fill each of these tubes with 0.9% sodium chloride, so saline solution. Gently invert to mix. Set that aside for the moment. Fill up this tube to this same height so that they can counterbalance each other when I centrifuge. Cap it and then gently invert to mix. And then these will be centrifuged for 1 minute at 3,400 RPM. 3,400 RPM for 1 minute. Our red blood cells are done spinning in the centrifuge. So I'll take them one by one and do a second wash. These are donor red blood cells. I'll remove the saline supernatant, and I am looking for it to eventually become clear and colorless, which tells me that the red blood cells are washed. It is pretty clear and colorless already, but we do need to do 2 more washes. So I'm removing all of the saline. And I'm going to resuspend the cells in new saline. Gently invert to mix. Set it aside while I do the recipient. Remove the saline supernatant. And this is pretty clear and colorless as well. A little more debris in there. And then resuspend in saline. Cap it and gently invert a few different times. Get those red blood cells from the bottom. And then recentrifuge at 3,400 RPM for 1 minute. Red blood cells are done spinning for the second time, so we'll prepare them for the third wash, taking my donor red blood cells, removing the saline supernatant, resuspending the donor red blood cells in saline for the third and final wash. Recapping and inverting to mix. Setting aside for now. And then repeating that procedure on the recipient red blood cells. And I'm choosing to pipette rather than just pour it off because I don't want to disturb those red blood cells at the bottom. Alright, resuspending in saline. Inverting going to mix. And then centrifuging them both for 1 minute at 3,400 RPMs for the third and final time. The third and final wash of the red blood cells is complete.
One more time, Patsy.
Take my donor red blood cells and remove the supernatant. And it is clear and colorless, which was our goal.
Okay, so normally stitches come out in 10 days, so a little past due. Would you be able to bring her in today? Like at 4 o'clock?
Alright, and I will make a 2% suspension in a clean tube labeled donor red blood cell suspension. And I'm going to place 0.02, so on my tuberculin syringe, it'll be right to that second tick mark, so 2/100ths of a milliliter.
Would that work? No, we just have to remove the stitches. Okay? Okay. I'll put her in. No problem.
So 2/100ths. And then fill the rest of the tube with 0.98 milliliters of saline. And that is my final red blood cell suspension for the donor. I will set that aside. Have my recipient red blood cells, the third wash. I'll remove the saline supernatant. And then in a clean labeled tube, my recipient suspension. I will get a new needle here. I will obtain 0.02 milliliters of red blood cells. .02 deposited into my new tube. So I'll discard my old tube and then add 0.98 milliliters of saline to yield a 2% red blood cell solution. I'm going to set up my major cross match. So my major cross match, I'm going to take 2 drops of recipient serum and put it in
Yeah, of course, no problem.
a clean labeled tube. This is my major cross match tube. So 2 drops of recipient serum. And 2 drops of donor red blood cells. Let me get a new pipette. So 2 drops for my donor red blood cell suspension. So recipient serum, donor red blood cells in my major cross match. And then for my minor cross match, I will take donor serum, 2 drops, the clean pipette, 1, 2. And 2 drops of my recipient red blood cell suspension. One, 2 drops. And that is my minor cross match. I will also make a donor control. So donor red blood cells with donor serum, 2 drops of each. 1, 2. Two drops of donor serum. 2 drops. So that's my donor control. Donor control. And then I'm going to do the same with the recipient control. So 2 drops of my slightly hemolyzed recipient serum. 1, 2.
I'm hoping I'm wrong.
And 2 drops of my recipient red blood cell suspension. 1, 2. All right, now that I've got all of my tubes, my major cross match, minor cross match, donor control, and recipient control, I'm going to mix them all gently and then let them sit for a half hour. So I'll show my setup here. Let all the tubes sit for a half hour. Major cross match, minor cross match, recipient control, donor control, sit for a half hour. It's been 30 minutes on our cross match agglutination. So since our samples are all the same volume, I will put them across from each other in the centrifuge and centrifuge them all for 1 minute at 3,400 RPMs. So that we can then do our agglutination testing. I'm going to look at each of the tubes to see if there is any agglutination, and I'll start with our control tube. So this is my recipient control, and the recipient serum was hemolyzed to begin with, so I am not surprised to see some hemolysis of the serum there. And so we'll take a look at the donor control. And their donor control is not hemolyzed, and the donor serum was not hemolyzed to begin with, so that's good. So we'll set those aside. Alright. We'll start with the major cross match. So the major cross match had recipient serum, which was initially hemolyzed to begin with. So it's a little hard to tell if this hemolysis is from the natural recipient serum or if there is more hemolysis due to the testing. And I'm kind of moving it around to see if I can see any macroscopic agglutination of the red blood cells. They seem to be moving fine, but what I'm going to do is transfer a small amount to a glass slide and look at it under a microscope for a microscopic agglutination. So I've got some red blood cells in there. I've got some red blood cells on here, and I'm going to look under a microscope just on low power. So a 40x power total. Focusing in. And I do see agglutination. There are big patches of agglutinated red blood cells. So I am definitely seeing agglutination in my major cross-match. And then I'm going to examine the minor cross-match and do the same. So my minor cross-match that has the donor serum, which had been clear and not hemolyzed, and I can see there is some hemolysis to this supernatant. So I'll take a clean slide. And a clean pipette. And I'm going to transfer a very small amount of those red blood cells onto the slide. And I can see they kind of came out in a clump. So macroscopically, I'm looking at it and I can see that the blood has agglutinated. But again, looking under low power 40x, have lots of agglutination. So the red blood cells have just all come together in pretty much one big mass. So then our diagnosis for this test would be that these dogs are not compatible for each other. If we were going to be doing a blood transfusion, these dogs' blood are not compatible for each other, because we are seeing that the blood and the serum from the different dogs is reacting and causing hemolysis and agglutination.